Oh, there we go. Okay, nice. Hey, come on in. My name's Dave, DMC. We've made something really exciting I'd like to show you, and we can play with it a bit as well if you'd like to engage, or I can also just demo it. We've got an hour and a half, but I wanted to take a little bit at the top to break down what this is, because it requires a paradigm shift. It requires grokking that this is a different way to build. This is a different way to solve. The headline is, no servers, no cloud, no masters. Build peer-to-peer apps. So 4 years ago, we started working on a concept, which is, can we build peer-to-peer applications and systems that require no server infrastructure? And it turns out that you can. We've built an app called Keat on top of PEAR. PEAR is the thing that allows you to build peer-to-peer apps. Keat has 1 million new users per month. It scales to the planet, and the infrastructure cost is essentially 0. Compare that to Dappcon with a infrastructure cost of 700 million a year, and you can see why this is a good idea just on practical grounds. We can build applications that currently exist. We can build new types of applications that aren't even possible with a centralized approach, that are real-time, that work almost identically to their equivalent apps, but with no infrastructure cost. Imagine you're saving 700 million a year on infrastructure cost. Where are you going to put that, right? It goes to things like business strategy, marketing, compliance checks, all that kind of stuff. So it also eliminates a huge amount of communication, because when you have infrastructure, that requires people to oversee that infrastructure, and that requires many layers of communication around that. You eliminate all of that, you eliminate a lot of noise within an application's development and deployment. You eliminate that, and you can, with say 4 friends, make an app that can do something at much higher scale than you could have before. If you can build a UI, and you can think a little bit in the peer-to-peer paradigm, you can build things that don't have any infrastructure cost. If you don't have any infrastructure cost, you don't need to exploit your users by their data, because you're basically taking a fire hose of user data exploitation, and then you're sending that fire hose straight through to pay cloud providers. So with this, you don't have to do that, and just on a basic human level, that feels right. Here's how it works. Use a module, deploy peer-to-peer, no cloud involved. That's it. We have a module, you take it, you put it into your project. It enables peer-to-peer over-the-air updates on desktop, on terminal, and coming very soon on mobile as well. So that means that you can deliver your application via the normal channels, but then any updates to that application come through as peer-to-peer updates. So you can deploy an application to billions of people around the world with no servers and have peer-to-peer over-the-air updates. Today, this is open source and available, and it's how we build. This is Keat. The beginning of this year, we had an uptick in usage, and Whenever there's difficulties and challenges in a particular country, and they start locking down communication and locking down internet access and different things, we see a big rise in that country of usage of Keat. We've not been marketing it, we've not really been advertising it, but as I said, we have 1 million new users a month currently, and growing.
Sorry, what are the two?
Oh, sorry about the confusion, yeah. That one's velocity, I think, but look at the green line. I need to get a better graph. So, pairs.com, peer-to-peer embedded application releases stack. If you'd like, you can scan that. It might still work. If not, I can sort you out later. But we can connect on Keat, and you can come into the pair development room. You might need Keat on your phone first. I don't think I've updated that QR code. It'll be on the bottom left of the screen. You might not be able to scan it, but don't worry. There's not that many of us in here. We can figure it out between us. The stack. We have a library called PEAR Runtime. You npm install that. This is a JavaScript thing right now. But the paradigms and the protocols apply to anything. The command line interface is PEAR. You use that to deploy your application. You can also use it to install applications peer-to-peer on desktop. Then bear. Yes, we have PEAR and we have bear. The logo for bear is a bear, but it's not spelt that way. It's spelt in terms of bare metal. And the reason it's called that is it's a Node.js-like JavaScript runtime with no core library as a very specific design choice. If you have no core library, then you're not granting any capabilities from the outset. If you have no core library, then it turns out getting mobile support is much easier. So we run anything that you need native-wise with bear. You just install it as a dependency. So if you need to use the file system in Node, you use the core FS module. With bear, you use the bear FS module when you install it. With that, it works on mobile, on desktop, terminal. We can deploy a single peer-to-peer backend on bear, on mobile, desktop, terminal, and then the whatever view layer is, so say it's React Native on mobile and Electron on desktop, that can talk to the same code that runs in the bear backend on that machine. So this is really nice, we found, as an architectural choice, because most people are used to the front-end, back-end paradigm. So we just say, OK, well, there is a backend, but it's local on device. You talk to it over RPC, and then that local backend does all of the peer-to-peer magic. Then there's the bare module ecosystem, and then there's the hyper module ecosystem, which is where we get all of the peer-to-peer capabilities. There's about, I think, like 2,000 modules on the whole Punch GitHub repo that this all extends down into. This all comes under the stack. I've said some of this already. We can skip it. The PEAR runtime module, the only thing I'll say is it has a run method, and that's for encouraging this architectural approach I'm talking about. You can npm install PEAR runtime and then use PEAR run within an Electron app or a mobile app, and it will start a bear worker, which is your peer-to-peer backend. This is the workflow overall. I'm just giving you an overall image of this, and then we're actually going to go through a little workshop and play with the tooling, but this is the full picture. You use PEAR touch to create a PEAR link. That's basically a deployment target. You use PEAR seed to expose hypercores to peers. So the way that it works is it's next generation BitTorrent called Kademlia, and that's seeded over a DHT. And then a topic, the PEAR link is actually a topic, which is then discovered via the DHT. So when an application connects to the seeded hypercore, it's connecting by the PEAR link key, which is a topic on the DHT, which allows peers to find each other. There's PEAR build, which creates a multi-arc deployment folder. So you've got Linux, Windows, Mac. You put those all in one multi-arc folder, and then that's what you actually deploy. pair stage synchronizes the files on your disk into a hypercore. That's the equivalent of the staging environment. So when you stage, you're actually at the point. In the workshop, we're only going to take it as far as stage because that just shows the functionality. But when you stage, you're actually at the point of doing peer-to-peer deployment. Because by synchronizing from disk into hypercore and seeding that to the network, you're exposing the builds. Your user installs the build. It connects to that to you as a peer, and when you stage the next time and you do an update, the length of the hypercore increases, and then that is replicated to the peers. The peers receive that as an update event, and then they can click a button and it applies the update to the swap on disk. That's how it works. Pair provision, sorry, I wasn't sure if it was a question, but there's a yawn. It's all good. Pair provision is a pre-release step, and it basically strips down the hypercore. Because every time you stage, if it's doing a deletion, then that's actually an append. So when you're staging to a hypercore, it kind of gets bigger and bigger and bigger. But when you do a provision, it strips out all the intermediate steps, and it's basically like a snapshot block sync, right? So that becomes a pre-production drive. That link, that pair link, you give to like QA teams, and that's when you're getting really, really serious. Like, we're about to go into production. This is how we make Keat. And then there's pair multisig, and that's the production step. With pair multisig, you have this pre-release key, this pre-release pair link that you've been QAing and all of that, and then you have stakeholders who are responsible for what's going out. So say you've got like 5 stakeholders, and then 3 out of 5 have to sign in order for that to actually hit production. So all of your users are using the multisig production link in their application, and the 3 out of the 5, say, if it's 3 out of 5 quorum, who sign, each one of those people who sign are saying, I'm putting my career on the line to say there are no supply chain attacks, the diffs look good, I don't see any bugs, I don't see any vulnerabilities, right? It's a very thorough process that is then signed off cryptographically with your public key, and people know that that's your public key. We've developed that process over the years because doing a peer-to-peer deployment, it's really, really important that it's done right and that it's done seriously. And the pair multisig command really hones the focus. So that's the full flow of how you deploy a pair app. It works like this. You have this dual distribution. So you do your builds like you normally would. You build your mobile app, you build your desktop app, whatever. You put it on a website, you put it in the App Store. The user gets it, they start running it, and then it connects peer-to-peer. From there, it's peer-to-peer updates. We've talked about Bear, so I'm going to skip this. This is the Bear ecosystem. I don't know if you guys have used Node or whatever, but the things in green are basically the equivalents of Node Core, and then there's a bunch of stuff beyond that as well, like Bear FFmpeg, which we use in Keat for certain things. Then there's the Hyper ecosystem. You have the Bedrock primitives. I've already mentioned Hypercore. You also have Hyper DHT, which is peer discovery, and then you have Hyper Swarm, which is peer discovery via topic. Then you've got the data structures, Hyper-B, Hyperdrive, and Autobase. Hyper-B is a key value store. Hyperdrive is a peer-to-peer file system. And Autobase allows you to do multi-writer. The really cool thing about Autobase, and this is what we use in Keat for conflict resolution of messages, is it has this apply function. So if you're on Keat and you're talking to someone else, you and that person both have an append-only log. I write a message, it appends to my append-only log, and then you receive that message, it appends to your append-only log, right? But it goes through this linearization process via Autobase. So the Autobase runs that through an apply function, and the apply function determines whether it's written and how it's written and when. And with that, what you actually have is tokenless smart contracts. Just something to think about. Storage and sync. Core store is for managing multiple hypercores. Local drive is the equivalent of hyperdrive, but for disk. That's how we do a stage. We just have a local drive that mirrors to a hyperdrive, which is what we use mirror drive for. So like I said, you have these deployment layers. You have this build flow. You have a deployment directory, which is your multi-arc folder. And then you have the staging layer, which you can just pair stage to. You could have a shared staging key. You could also just touch a new link, stage to that, give it to a colleague and say, hey, can you just check this over? Or like, I'm struggling with this or whatever. It's really, really easy to create variations internally that no one else ever looks at, even internally, just between you and someone else. But then you can also have, like, these are the official links between us. So we have a development stage key, we have a staging stage key, and we have a release candidate stage key. And it goes, that's an additional process that we have, where we're going through each stage until once we get to the RC key, it stays on there for a couple of weeks, and then once we're like happy with it, we do a provision, and we create the pre-release key. The pre-release key is like I said, a very, very serious moment. Like at that point, we have QA check the RC, but then QA check the pre-release key as well. If there's any problems with that, there shouldn't be any problems at that point, because what you're saying with the pre-release key is like, if we'd have gone to production today right now, this would be it, right? And then once that's been verified again, then you do the multi-sig and you go into production. This is just a release cycle. Every time we're going to look at the Hello Per Electron boilerplate. But basically, every time you bump the version, that's to create a new build, and the updates are based on the version increasing. So you version it, you make the distributables, you build the deployment directory, you stage, you provision, you prepare the request, you sign, you verify. Once you've got the signatures, you commit, you're in production. So we've got different quick start guides. The one we're going to be looking at is the Electron boilerplate. Don't worry, we'll come back to this. We also have a PEAR boilerplate, which is for creating peer-to-peer terminal applications. So CLIs, REPLs, daemons, services, hooks, whatever you can make in the terminal, you can now make as a application that has peer-to-peer over-the-air updates. PearPass is a product that we've made, which is a password manager. You can't leak clear text passwords if the thing doesn't have a server. Like, you eliminate all of that, and you just have it between your devices. It's about personal data custody, right? QVAC is a local LLM project. There's a lot of optimization for running LLMs locally. This has a really nice parity with our peer-to-peer stack. One of the things that QVAC can do is remote inference. So if you have a nice beefy machine with some LLMs on it, you can use QVAC with our stack and use it on phone for like the easy stuff, and then offload compute for the remote inference. And of course, that's all completely private, and it's all completely your machines, your data. And then, of course, Keat. And like I said, we've discussed that. If anyone wants to connect with me on Keat, we can later on. Same for that. There's a news, pairs.com news, check that out. docs.pairs.com to learn how to build. And careers.tether.io, because we are hiring, like, actually a lot. We need people of all kinds, front-enders, back-enders, cryptographers, whatever you are, we're probably hiring. So have a chat with me if you're interested in that. I certainly would be interested in that. So any questions before we get into the workshop? Yo.
Thanks. I really like what you guys are building. I've been following since the beginning.
Of everything that. Oh, yes. Thank you. There's one thing that might be a stupid question based on what you just described, but I'm building an app that has quite a few users at the moment, but in order to make it as accessible as possible to the general public, it's a web app.
Sure.
It's a web app. We try to keep everything local on your browser, and when you need, you sync with end-to-end encryption, etc. Are you thinking of introducing anything in your tech that could be applied to web apps like mine that try to maintain the best security and privacy as they can?
Yeah. So that question has been asked many times, and the answer is unfortunately always the same. Browsers are controlled by specs. Specs are controlled by organizations who have a vested interest in remaining centralized. In order to do the kind of peer-to-peer that we do, you need UDP. Browsers don't have UDP. I don't expect they will ever have UDP. It's not a technical problem. It's a political problem. So our response to that is to go 100% on apps. However, you can just, like I said, you can create like a PEAR process with like OTA updates or whatever. So you could create a server that's a portal into a peer-to-peer landscape and then progressively enhance from there. So you can have a web app that gives your users as much as you can give them, and then after a certain point, when you have the scaling need or whatever that feature is, then you onboard them to the app, which is a pretty normal flow. And we haven't decided to do that for us because Keat is a messaging app, and it doesn't necessarily make quite as much sense as a web app then. But I do think that there's other types of apps that you might build where you're going to want a portal, probably.
Super, thank you. And last question. So we're indeed also preparing some desktop and mobile apps. So slowly taking the users into something that's much higher friction. But for us, it's document collaboration, spreadsheet collaboration. So you have 100 people editing the same stuff. You need CRDTs, etc. Do you think that at the moment what you've built is already at a good stage to handle applications that require, I don't know, 1,000 edits per 10 seconds by so many sources?
100%. 100%. Not that it's easy, but the key is that every edit needs to be you don't store the latest state, you store every edit that's made. And if you do that, then you've got undo and redo and all that built in. But you're taking advantage of the append-only log. And then the auto-base apply, you would need auto-base for this, for sure. And then the auto-base apply function would then be deciding who wins, or it might even have, you can do it any way you want. You can even do it for certain situations where it sends it back to the user and it makes the user decide who wins, right? But there's many ways you can do that part. As long as you're not trying to store latest state, as long as you're actually storing every single edit, then 100%.
Thanks.
Sure. Any other questions? Yeah. I mean, yeah.
Wait, I'm coming.
Oh. Thank you.
Thank you. So, yeah, super interesting, first of all. Who's running the DHT server nodes? Maybe.
So every peer can be a Bootstrap node, but you need the IP addresses of the Bootstrap nodes. So the Keat app, for instance, has a couple of Bootstrap nodes hard-coded, and we run those, right? But if you're making your own app, you can set up your own Bootstrap nodes and run them. And or you could make it so that your users could supply.
Would these networks then, or these DHTs overlap? Is it like one giant DHT where all the apps would register themselves, or does each app have their own?
By default, the first, but if you'd like to customize the second.
Right, okay, got it. And how's the research usage of a DHT client on mobile? So this has you.
How do you mean?
So for example, back in the day, I'm not sure if they're still around. Bertie, they used to run a DHT client on mobile devices, and what they were suffering is like this was just draining the battery because you had to keep the routing table up to
the
date
antenna
and
problem.
so
Yeah.
on.
I'm going to answer this in a roundabout way because hopefully it makes sense at the end. So if you're not online and I send you a message, you can't receive that message because it's peer-to-peer. But if we have blind peers, then those blind peers can receive the messages and forward it on to you encrypted, which is how we solve the availability problem. But mobiles will never be blind peers. So they're not every peer has to be the same. Mobile will probably always stay as client peers, and by doing that, you reduce a lot of the battery and energy cost and all of that. Yeah. But it's not, it's not a foregone conclusion. It's still there's still definitely some trade-off there. But I think I know, like, because I use Keys all the time, the capacity is sufficient that it works.
Yeah, I thought so. That it's fine. I guess. What else do I have here? So, I mean, P2P networking is hard, so you're probably employing some hole punching techniques, I guess?
When we first started doing this, we called the company Hole Punch, because our secret sauce is the hole punching technique.
Right.
I can't speak to that so much because that's the bit that's where I came in once that was built.
Right.
But as far as I understand it, it's a statistically guaranteed method to opening the gates on the NAT routers, and from what we can see, it works very well, which you can see in the data because a lot of those million new users a month are actually coming from Russia. We have some conversations with people inside China, with having conversations outside of China. So it's effective. Right. And then,
cool.
But it's not 100% effective. For the 1% that it's not, then it goes through a blind peer actually, but as a relay.
Exactly. Yes, this is exactly what I wanted to know. So what the fallback mechanism looks like.
Yeah, it's just a message, so it works via a blind peer as well.
Yeah, sure. You mentioned UDP earlier. Does PEAR support like TCP transport or plus quick, or are these just raw UDP datagrams that you're sending around?
It's our own flavor. It's called UTP, I think, which is just UDP plus. So it's TCP-like, but it's not TCP because it's optimized for what we're doing. Okay. But PEAR supports TCP. I don't know if it supports quick, but you could write a native add-on just easily, right?
Is this all written in JavaScript, or is it just a shim or like a layer?
JavaScript and C.
Sorry?
JavaScript and C.
JavaScript and C.
So we find JavaScript's really good at rapid prototyping, rapid iteration. We have practices and have a pretty strict subset, but it's fantastic for getting there quickly. It's fantastic for onboarding people. It's such a commoditized language, and then with pairing that with C as well. So C is for the native add-ons in PEAR, and then you have this thin, JavaScript layer on top.
To me, it just sounded like an unintuitive choice of using JavaScript for such a low-level system problem to solve. But you mentioned C as
Yes, there's C, but I think for something like this, JavaScript as an evented language is excellent for the mediator pattern, and in peer-to-peer, it's all mediator patterns. So I think it works really well, particularly for the mental model. But we are, as we move forward, more and more of the stack is being moved into C, because of efficiencies and cross compat and things like that.
Cool. Okay. Maybe one last question.
Sure.
So is there So you may have already touched on this, but in other P2P libraries, there's next to DHT, which is used for peer discovery, also some gossiping protocol. Is there anything like a module that supports any kind of gossip?
A little bit out my area, but I believe Kademlia is responsible for the gossiping. The Kademlia, it's a next generation BitTorrent algorithm that we use right down deep in the stack. You can
So
find that
yeah,
under HyperDHT.
Okay, so the DHT is just a key value lookup thing. So if you want to disseminate a certain message across within the entire network, there are like probably other protocols. I will look it up if there's anything.
We have something just on that, just as a side note. We have something really, really exciting come in that's not been released yet. It's still in the works, but search via DHT as well.
Interesting. Okay. Okay.
So that's a global search engine at that point.
Good. Okay. Anyone?
Any other questions before we get to the actual workshop portion? No?
Okay,
Cool.
I would have yet another one then.
Okay.
What did you want? Okay.
We can take one more and then one more if you want.
Right.
to do
Okay.
that.
The hyperdrive that you mentioned, is this in any way content addressed? Is content addressing is it playing a role in this whole stack that you mentioned?
When you say content addressing, you're talking about content hashing of
Yeah.
the content.
Yeah.
So pair links are a standard, and it's the pair protocol and then a key string, but it can also be the pair protocol fork.length key string, and then it can also be the pair protocol fork.length key string hash content hash or something like that.
Right. Okay.
So we have all of the forms, and if you want to use the full content hashed version, you can. But with the fork and the length, you're pointing to a very, very specific thing in a hypercore at that point. So I think there are probably, like, if you're ultra paranoid, you can use the full content hash, but mostly we just use fork length.
Okay. Cool. Good. Thank you.
Yeah, sorry, I missed the beginning, but what I've heard is that you're making a distributed hash table kind of storage.
Sort of, but much more than that. It's a way to build applications at planet scale without servers.
But how does that differ from something like Swarm or?
Swarm? As in DHT Swarm?
Ethereum Swarm,
Right, yeah, not too keyed up on that. I don't know, can't compare them, but there's no tokens involved. Maybe that's the key point.
Thanks.
Stick around for the workshop and we'll get into it. Okay, cool. So if you'd like to follow along, take a look at github.com/holepunch2. Wait. Where's it gone? Pair workshop. Let me put this in bigger letters so it's easier to see. Everyone got that? Anyone need more time? Yep. Cool. Okay. So to do this workshop, you need to have Node installed. Because we use npm, we don't use Node with PEAR. Actually, PEAR is everything, but we use Node and npm because those are the things that people use. We don't use Node, sorry, we just use npm, but you need Node for npm because that's what people use to install dependencies. So if you don't have it, you can get it on Mac with nvm.sh or on Linux, and on Windows you can get it with nvs. You see it in the workshop. Oh, good. To install PEAR, you just run. Oh shoot! Hold on, let me just sort myself out of it. But you run npx PEAR. Now, if I run that, it's going to do something different, I think. You know what? I'm going to remove PEAR from my system just to show you how to do it. So what this is doing is it's executing an npm module that downloads PEAR from peers and installs it onto your system. The PEAR itself is actually a bare program. And the next version that we're going to release is also going to be using the same P2P OTA updates with bare approach that we published recently. Once you have it, you should be able to, you're going to need to export, you're going to need to modify your path. You can do it by running this command here. I don't need to because I've already done it. And then if I run PEAR, I should see some help output. Come on. There we go. That's a Mac thing. That's not a PEAR thing, by the way. When you put a new binary on Mac, it actually does a call back to Apple, I think. So this is the PEAR help. You can see some of the commands I talked about there: touch, seed, stage, build, provision. There's some other cool stuff. Info, dump is really cool because you can dump whatever you stage. So it's synchronizing from your hypercore back onto disk. Changelog is really cool, really fun. All right. Anyone need help getting PEAR installed? Because it's not as easy as it could be. Everyone good? All right. Don't forget to do this part. If you don't set up your path, you can't run it because it's pointing at a custom bin folder. In future, that's going to change. So once you're set up, you can go to the first exercise. And what we're going to be doing is we're going to take the boilerplate. How much longer do I have, by the way? Like 45 minutes or so? 50 minutes?
Well, officially the workshops end at 3:45.
Great, perfect. Lovely, thanks. Okay, so we've got this boilerplate, hello PEAR Electron, and we're just going to git clone that into a chat app. So I'm going to go git clone. Oh, did it twice. Git clone hello PEAR Electron into a chat folder. Let me make that a bit bigger. And then we're going to do run this command. And what that does is just sets the package.json name, the package.json product name, and the package.json version. The product name is what's used when we actually do a build. So typically it has an uppercase letter in it. And the package name has to be lowercase. That's why we do that. And then I'm going to npm install. While that's happening, let me talk you through the boilerplate. So the boilerplate is, the README of this boilerplate has the full explanation of how to do this end to end. Talks about the architecture, talks about how the updater works, talks about where the storage lives, how you can set your own storage flag, which is important when you're developing peer-to-peer applications, because it's all about where something's stored. So if you run two applications locally with different storage targets, then you're simulating a peer-to-peer interaction locally. They actually go and connect outside, and then hole punch back into yourself. That's why that's important. The workers, which is the back-end stuff, it talks through the deployment stuff I've already been talking to you about. You can see some of these diagrams are quite similar. So this is something you can work through like end to end to get to a full production deployment of a PEAR app. Now that's installed, I'm going to do npm start. Oh, my bad. I missed a step. So the package.json has an upgrade field, and it says your key here. So we need to give it a key that we're going to stage to later to do peer-to-peer updates. So I'm going to run PEAR touch and that's given me a key, which I'm now going to take and I'm going to set on the upgrade field, like this. And now npm start should work. Great. So that's launched an Electron app, and it just says what the version of the app is. I hope someone hasn't died. That would be terrible if they have, after saying that. So that's that, exercise 2. Now we're going to make the actual chat app. So what we have here is a little diagram of the flow between the pieces of the Electron app and a remote peer. So the Electron app, it has renderer app.js. It has preload.js, which is actually part of renderer, but it goes through this context bridge thing. It's Electron stuff, don't worry about it. And then there's Electron main.js, which talks to the renderer. And then there's workers main.js, which is bare runtime. That's what's running the actual peer-to-peer code, right? And that's all talking over IPC, RPC. Then from that, it's doing a write to the peers via Hyperswarm. Every time Hyperswarm detects that a new peer has joined, you get a peer object, and then you can listen for data on it, and you can write to that object, and that writes to the peer. So, we're getting the data flow is going from the front end UI, the web view, over to Electron main, over to the bear worker, over to the remote peer, back from the remote peer, and all the way back into the renderer. So to do this, we're just going to install some dependencies. We need Hyperswarm for the DHT, Hypercore Crypto, and B4A, which is just a buffer manipulation dependency. So I'm installing those now, and then copy paste. So we're going to take workers main, and we're going to put this code in it. You can see here that we have a Hyperswarm. We set it up, const swarm equals new Hyperswarm. When the swarm gets a connection, it gives us a peer object, and then we're listening for data on that peer. And then we're calling our send function that we've made with this object. The send function is here, and all it does is it writes to this pipe, which is a frame stream over a socket, essentially. Bear.ipc is the socket. When you start Bear as a worker, bear.ipc is the socket to the parent. And then when data's coming in, we take the message, and then depending on the message type, we either join a swarm with random bytes, or we join a swarm with provided bytes. So that means like that's the same exact flow from there for creating a chat room or joining a chat room. And then if it's a type message, then we loop through every peer that we're connected to, and we just write the message text to them. And that's it. That's pretty much that's the whole thing in terms of all of the peer-to-peer logic for a ephemeral chat app. There's no persistence here, but that's everything. So I'm going to put that into workers main.js, like so. Oh, wait a second. Someone's updated this. I'm going to keep the, what we also have in workers main right now, and it's a good thing, but this needs updating in the workshop, is the updater is running in the worker. The updater used to be running in Electron main, so I'm going to copy paste that code, but it's going to go between these lines here. Hopefully this works. I'm not sure if it's going to work because it's a bit, I have to debug it if it doesn't. That's fine. And then got some HTML here, renderer index.html, which we're going to just replace verbatim. You'll see it. All it is some chat stuff for joining and creating rooms. And then renderer.app.js will give us the glue code for receiving data from the worker and vice versa, and making that work with the UI. So that is renderer.app.js. There's not an update. Okay, I'm not going to approve updates for the chat app. That's just not going to happen. Right, now that's done. npm start. And then we've got a chat app. And then if I create another process, npm start with a storage flag. Oh, that's the wrong Now I have two instances of the chat app with two separate storages. So you could also, if anyone's got it running on you can also join, but let me know if you have it there. So if I create a room here,
What is happening now? So is there something happening? Like registering something in the DHT now?
yeah. So when you press create, it joins the room with the random bytes. So we're creating a topic on the DHT join room. That should be happening faster, but I've just realized I'm on my, I need to get on that. Let me try it on Dappcon guest. And then the idea is that you then join that topic on the other one. I don't know why that's being weird right now. Let me try creating one on this one instead. Cool, just checking. Yeah, so the boilerplate's been updated, and there's a little mismatch here. I'm going to have to debug this real quick.
Works on my machine.
Does it?
Yes.
Fantastic.
But I didn't, so I used the code from the README Dappcon. So I didn't do your...
Yeah, you didn't do the little thing that I did. Let me just do that and see if that works. Okay, cool. So I've got this topic, and then I join that topic, and now I have are you on Keat at all?
No.
So I'd share the link with you on Keat. So that's the thing, you have to share the topic out of band some way or another.
Yeah.
But if I gave you this topic, it would work. A lot of the time we do this as a remote workshop, so it's really easy then because you're like in a Zoom call or something, you know. But trust me, it works. Any questions about that? About that build?
Maybe this IPC thing, what is it exactly?
What, the bear.ipc part?
IPC,
Yeah.
how the socket thing works. So, yeah, so I have suspicion that maybe. Oh, okay, thank you. Yeah, good. How does the bear.apc IPC thing work? I said I have a suspicion how it works, but maybe you can explain it again.
Sure. So electron main.js, right? We have pair runtime run. And that, what it's actually doing is it's running bare sidecar. Bare sidecar is just a duplex stream that spawns a bare that's packaged in as a dependency, but it's just a native. It's still just a native binary per OS that you just install it in, and then the IPC is the stdio3. So you've got 0 for input, and then 1 for out, and 2 for error. We do FD3,
Right.
and that's just the pipe then.
Okay.
Yeah.
Cool.
Nice.
I
Anyone else?
was just wondering if it's, I don't know, if this is a Unix domain socket or how you connect all of these pieces together. But okay, this is different from what I expected, but it's cool.
This is after like 4 years of iterations, and it's where we sort of landed for, it's not just about like the technology side of it. It's about what makes sense with lots of people working on something at the same time. And helping people framing things in a way where it just makes sense to like onboarding people quickly, because that's what we've been doing a lot. Let me also show you. Sorry, I'm just going to go off piste here and just go do whatever. So I want to. I'm going to clone the boilerplate again, and just straight into hello pair electron, because then I can show you the update flow because of that little wrinkle there. So npm install. And we're going to do pair touch again, create a link. I'm also going to set the version to 0 just to confirm it. And then npm start. Great. So now what I'm going to do is I'm going to do npm run make a build. So what I'm doing is I'm going to go through the productionizing flow, and then do a peer-to-peer update, and you'll see the version hopefully change if I don't mess it up. So I've got some artifacts here. Great, that works. So now once you have a build of an app, you can use the pair build command to piece it together. It's a really simple command. All it's doing is copying, but it's about structure, right? The point is that you want to be able to build on Mac, on Windows, on Linux, and then put them all into one folder. At some point, we'll extend the functionality of pair CLI to make that easier, because we could totally leverage our peer-to-peer stuff for making like a build farm or something. But at the moment, it's like manual on purpose because there's less that can go wrong. I'm building on a Mac M1, so this is a Darwin ARM64 app. So I'm going to do pair build Darwin ARM64 app out hello pair blah 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 hello pair app. And I'm going to set a target folder also for out build, let's call it. And I also need to provide a path to the package JSON. And that's really important, because what a build folder is the multiple architectures, and then a package JSON at the top that has that upgrade field on it. And that's what it all comes down to, is that package JSON at the top with the upgrade field on it. So if I run this, now in the out folder I should have build. Yeah, so this is it. You've got the package JSON at the top, and then you've got the BIARC folder, just with Darwin ARM64 in it right now. But you know you want to have, like, for a full production app, you're going to have everything. So with that, what I can do is I can cd into the build folder, or actually I'll do it from the outside. Hold on. So out build is the deployment folder right now. So I'm going to pair stage to the upgrade link, which is this. And the pair stage command looks like this. Pair stage flags link dir. So I'm going to say pair stage with the link, and then point it to, well, sorry, I'm going to do a dry run first. Always dry run first. And then that's out build. That's my deployment folder, right? So once I've run that, you can see that it's printed out this diff. Pretty big because it's an Electron app and it's the first stage. But the point of the diff is to verify that every change that's happening is intended. And that's why I dry ran it, because it's not actually written. It's just shown me what changes it would make. So now I'm going to run it again without the dry run. Cool. And now I should be able to seed this link. And that's now exposing that link to the DHT. So if there's something else really cool that I just want to show you that's on the side of this. We don't have this out yet, but that will fail. There's a pair install command coming, but you can preview the command with npx pair -install and then a link. So if I run that, it will install the build that I just made from myself. You can see there was a join on the seed there. That's this. That's going to install it into my applications folder. So it will install UI applications, and it will install command line applications. So there's a side advantage here that the same update drive that you're using everything actually can be a peer-to-peer install source as well. So if I open applications hello pair now, oh, don't be like this. That's not the one. Let me try again. Great. OK, maybe that was the one. Now, when I opened it, there was a join that popped up on the seed. If I was to give you this app and you opened it, you would also join in it, right? So now I know that this peer, this app that's now a peer, is ready to receive updates. So what I'm going to do is I'm going to make a change. And all I'm going to do, because it prints the version, I'm just going to bump the version, right? So I'm going to do nbm version patch. Oh, the git directory thing. I'll just do it this way. Yeah, I'll just do it manually. So I'm going to bump the version, and then we go through the build flow again. So it's npm run make. And then once we've made it, we build it again for the multi-arc folder, and then we stage it again. And then once we've staged it, the update should go out. So pair build again. Everything's exactly the same this time. And now pair stage. Going to dry run it first. And we can see this time the diff is much smaller, right? Because we've only made a small change. The things that have been updated are updated by the Electron make flow, some plist stuff, some that Windows stuff, the package JSON itself inside the app, and then the top level package JSON. They're the same package JSON. So that all makes sense to me. So now I'm going to run it without the dry run. But before I do, let me make sure to have this app visible and the seed visible. So I'm going to hit return in this one. So that's staged. Yes. Good. So that should come through, but it's not yet. This is always the bit where I'm like, oh, God, it's not going to work, is it? But I might have to restart it to get it to work. I'm not sure why that is, but it generally happens when I'm on the same machine. But if I'm using two machines, it doesn't happen, you know. So you see that the length increased here from 1263 to 1273. That's the thing. That's the version. That's the peer-to-peer version, right? If I do pair info of the link, then it should tell us, OK, it's 1273, so we know that it's been updated. But the app has not received the event. Of course it's not. So have we got any errors? Like I say, this was updated recently, so it might have been broken. I don't see errors. Let me try shutting it and starting it again. Sorry, I'm just trying to think about why this might be. My bad. You could just trust me that it works. It's how we do updates in Key all the time. We know it works, but I think we have a lot of guys that are contributing all of the time and improving things, and it's possible that there's a bug that's come in here between the last time I checked and now. That's the peer join. Oh, OK. That's weird. I restarted the seed, and then it started working. So I'm going to take that back to the team and figure out what the hell's going on there. But you can see that it's actually picked up the update this time, and it says updating. And you can also see that there's an upload from the seed happening, because it's uploading to this peer over here. And it says the update is ready. Still downloading there. That's weird. Or uploading. And then if I press apply update, it restarts with a new version. That intermediate bit, I need to research exactly what went on there. But like I say, when it's on the same machine, it's sometimes a little dicier than on different machines, but I'm not sure if that's something to do with it. And with that, you have peer-to-peer over-the-air updates.
So this update now went through the internet though?
Yes, it went out and back in. Yeah. Any other questions? We've got a cool snake, like on the workshop, you can keep going through, and then we've got like this cool game that we've made called Snake. I don't know if you've heard of Snake before, but this works on exactly the same concept as the chat app, but instead of it being chat messages, it's structured data that determines the position of a snake. But it's the same architecture. It's the same exact thing all the way up and down. Here you've got like the frame stream, you've got the updater, you've got join game instead of join chat, right? But it's all the same thing. You're just joining a swarm with a topic. The two peers connect, and then they can play Snake with each other as well. There's a whole part 2 that you can take a look at here, probably in your own time. But if you work through part 2 of this workshop, you can go through the same deploy flow that I just showed you, without. But you can take it further and go to provision and multisig as well. I could show. We got a few minutes. I could show the provision stuff. So let's say that we're at a point with this link that we're like, okay, good. Version 0.01, that's the production version, right? So the next step then is to go, okay, well, it's time to create a provision drive. So I run pair provision, dry run, and it takes a versioned source link, a target link, and a versioned production link. When you're creating your first pre-release key, or your first provision key, there is no production link yet. So you just use a 0 versioned link, but what it does is it synchronizes everything from the version production link onto the target link, and then on top of that, it overlays everything from the version source link onto the target link. And that way you have a replica of production first, so it's always correct, and then you have your changes on top. So I need to create a new link for this, so I'm going to do pair touch. And I actually need to create a new version now because, and this is sort of a problem for CI or whatever when it comes down to like a proper deployment. But I now need to update the upgrade link. I think actually we've got a thing where you can do, I'm not going to do it here, but you can do like develop like stage and then production and then have a link per. But the raw way is to update the link. So I'm going to update that, but then I need to also stage that because we're going to be syncing from the stage link as a source. So I'm going to go pair, stage, dry run. Oh wait, sorry, I need to do a make first. So npm run make, and then I need to build, and then I need to stage dry run, and then it's got the provision link that we've not provisioned to yet. So now build, and now stage dry run. Yep, that looks correct. And then without the dry run, and now I can do the provision. So my stage drive is aligned with the future provision drive. So now I go pair provision. The source link is the versioned stage link. So you can actually find the version stage link in the stage output kind of discreetly here. And now the target is what we've just set the upgrade field to. And that doesn't need to be versioned. And then finally, there's a production link, which we don't have yet. So I'm going to pass in the source link at 0, 0, so it syncs nothing to start off with. And don't forget to dry run first. I think because this is the first one, there should be a diff, but because it's the first one, there's not. So this is saying, yeah, good to go. Now I provision. So this is getting more serious, and it says, like, are you sure you want to do this? I'm waiting 10 seconds for you to bail. And then when it's done, it should then have synced, and we can seed that. And what I'm going to do, just to make sure that it's worked, is I'm going to remove hello pair from my system. Oh, because it's running. And now I'm going to try to do that install again with the provision key instead of the stage key. See the join, see the upload. We didn't need to bump the version for that build. Generally, you always bump the version, but because we're swapping the upgrade key out, you don't need to bump the version because you're starting with a new key, a new link. Now it's been installed to the applications folder. Open it, great, cool. So this is now a pre-release link. The step after this would be pair multisig. And this is where it gets a little bit heavier. We're not going to do this. We don't have time. But the flow is this. You create signing keys. So each signer needs to generate their own key. So it would say, like, myself, yourself, maybe you, right? And then yourself, and then yourself, and that's 5 of us, right? And then we're going to say, okay, each person is going to generate a key with a password, and that's then that writes that out. It's sort of like SSH, right? To this .pair folder in your home. So that's your public key for signing. And then what you do is you create a pair.json file in the project root. Oh, it's already there with those public keys. So I've just lost that. Pair multisig keys get. Cool. Yeah, it creates it if you don't have it. Otherwise, get will just give you your keys. So that would be the first key, and then maybe I take 2 more keys and we just do a 2 out of 3 quorum, whatever. Once you have that, you then run pair multisig link. Oh, I need to hold on. Let me just fudge this. I'm going to do a 1 out of 2 quorum, and hopefully it lets me use the same key. Fuck. Uh-huh. See if pair multisig works. Multisig link works this time. Ah, God damn it. Cool. So once you've set up your pair.json with your quorum, you use pair multisig link because instead of pair touch because it's determined by your multisig configuration. If you change the signers, you need a new link. If you change the quorum, you need a new link because it's basically a contract at that point, and the link represents the contract. And then that would be then set, that pair multisig link would then go on the upgrade field, right? And then you'd go through that whole process again, where you'd like stage the new multisig link and you'd provision the new multisig link, because this is now about production. And then you'd go through the multisig flow, write it to that link, and then at that point you've actually reached the production piece where you can actually give this to your users. You would version, you'd make the distributables, you'd build a deployment directory, you'd stage. You've seen me do that a few times already, right? And then you provision. And then you go and write pair multisig request, right? So I wonder if this will give me a little preview if I do it like this. Pair multisig request. I'm going to version it as 0.0 and see what happens. That's going to freeze. No, it needs to be seeded. But yeah, so I've not written to it yet, so I can't do this part. But with what pair multisig request does is it creates a signing request that you then give out to your signers, and then each signer runs pair multisig sign and pastes that signing request in, and it signs it with their keys, and they give their responses back to whoever's actually running the release, right? So say it's me, I get my response from you, I get my response from you, we put them together, and then I run pair multisig verify with the source link, the multisig link, the signing request that I sent out, and then all of the responses. That's basically a dry run, but we've made it a separate command because it's that important a step that it should have its own command. Once you know that that's all good, then you can run pair multisig commit with the source link signing requests and responses. And at that point, it actually writes to the link, and then any users that are using your app will receive an update and get the update and go through that flow that we've already seen with stage. But that takes us to the conclusion. That takes us to the full end-to-end flow of creating production and deploying and installing production peer-to-peer apps. So questions before we wrap, or how are we feeling? It doesn't have to be a question. It can be a take, if you like.
Pretty cool.
Ah, that's very nice of you. Anyone else got any compliments for me? All right, cool. Does anyone, if anyone wants to connect on Keat, we can just do it. We can wrap now, we can finish this, and then as soon as I figure out where I've put my phone, we can connect on Keat. Here it is. I'll